All right, this is for Algebra 1, and this is a recap of what we did on Tuesday, April 23rd. So just real quick, just to refresh your memory and to tell the ones who were gone, we took a tennis ball, and that tennis ball, we had somebody was throwing the ball, someone catching it, and someone timing. So basically, when you threw the tennis ball, it created like an arch. And so we are looking for the max height of that tennis ball, and this is what we call the vertex. And we were also looking for the time it took to reach that max height, because we can't just bring a ladder out and measure it and try to figure out that max height. So we used some formulas. So what we did here, we have this formula, this negative 16t squared plus vt plus c. The v is your velocity, c is your starting height, and then h is going to be our ending height. So the negative 16 comes from the force of gravity, the pull of gravity. It's pulling down at 16 feet per second, I believe. So velocity, we figured that out. We did the velocity equals 16t using that formula. We figured out our time. So you guys, a lot of you averaged all your trials together and did an average of whatever time that you got there. So then we figured out our velocity, and the initial velocity of going at 48 feet per second if you use 3 seconds. And that's 16 from up here. Then down here, you use the formula. We knew the velocity was 48, and then we did the vertex formula, or the vertex form, which is negative b over 2a. So I'm just flat out giving that to you right now. We'll go in more depth after the EOC of where that's being developed, but that negative b over 2a, or the opposite, I should say, the opposite of b over 2a, gives us the amount of time it took, if that was 0, if our starting height was 0, our velocity was 48, and we had that negative 16. So the opposite of b, so that's our b term, 48, and then twice the negative 16. So whatever you came out the time. So on my example, it took me 1.5 seconds. It took me 1.5 seconds from throwing it to reach the maximum height, and then what we did with that time, we plugged it in for the time. Make sure you square it first, and make sure you're squaring properly, not multiplying by 2. That's what some of you guys were doing yesterday. So square it first, then multiply negative 16, multiply these, and get whatever, and then make sure you have a negative here. That needs to be a negative in this one. So then some of you, I think, had like 97 or something, was probably way too high. You probably added these together versus that being a negative, so check that work. So on this case, with that tennis ball yesterday, it took us 1.5 seconds to get the max height of 36 feet, or whatever your numbers were. So today, now you're going to be doing the same thing. You're applying the quadratic equations, which this is a quadratic equation. When your highest exponent is 2, the greatest exponent is 2, and it's the 3 terms, the 2 actually is your quadratic equation. So we're going to do the exact same thing on these scenarios and follow these steps here. Okay, so you're going to start with this formula. So formula models the projectile up in the air and then falling back down the force of gravity. H is the highest point in the arc, T is your time, V is your initial velocity, and C is your starting height. Always read what they are using the letters, because I have seen some that have different letters here. So always read what they're representing those letters. But these things usually stay the same: the time, the velocity, the starting height, and the H, the ending height. Not really your H or ending height, your highest point in the arc. Our vertex formula, okay, so using this to find the number of seconds it takes for each projectile to reach its maximum height. And then finally submit your answer for T back into the quadratic to predict the height it'll be. And don't forget to answer with a sentence. So we'll talk about what that means. So we're going to look at this scenario. Diving Danny starts a platform of 50 feet above the pool, assuming starting with an upward velocity is 8 feet per second. How many seconds will he reach the maximum height, and what will that height be? So I'm a big fan with these type of problems is to draw a little picture. Now don't get overwhelmed and go totally off task. But let's say this is the diving board. This is the ladder. This is the diving board. Here's Diving Danny. Very happy. And this is 50 feet above ground. So this is 50 feet up. And assume he's starting with upward velocity, which means this is like the diving board probably bounces and goes up 8 feet per second. Okay? And then he dives in the pool. So we need to know, oops, that's not the 8. we need to know what this max height is and how many seconds it takes to get that height. So we're going to use this formula. So we have the h equals negative 16t squared. Now that's our max height. We don't know that. Negative 16t squared stays the same. The velocity, here's where you're going to substitute the v for the 8 for the v. So our 8t, and then we start at 50 feet above the pool, 50 feet above the water. So this is the water, beautiful water, and that's no longer 0. So you have to read on where they start. So then we need to find, so the second thing, you need to find the time. So the time's going to be the opposite of b over 2a, which the opposite of b is 8, so that's going to be a negative 8. 2 times a negative 16, that's going to be negative 8 over negative 32. Now, this is going to be positive. If it's negative, you probably dropped a sign somewhere. You can't have negative time. So you're going to have, that's going to be 1/4, which you could say 1/4 of a second, or change it to a decimal. And actually, I would leave it as a fraction for this, just looking ahead. So you're going to plug in the 1/4 squared, or 1/4 squared, plus 8 times 1/4 plus 50. With these numbers, I'd keep it 1/4, because 1/4 squared is 1/4 times 1/4, which is 1/16, plus 1/4 of 8 is 2. Now do all this work. Don't do it all in your calculator and just write down the answer. Show what you're doing, so then if there's a mistake, you can find it. Okay, now negative 16 and 1/16. Okay, these cancel, these 16s, and that's going to be a negative 1. Whoops, why did I do that? Negative 1 plus 2 plus 50. So negative 1 plus 2 is 1 plus 50, so that's going to be 51. Okay, so what that means, at 1/4 of a second, his max height is 51 feet. Meaning he started at 50 feet already, so he went 1 foot. When he bounced off, he went 1 foot. So that sentence is like in 1/4 of a second, or 25 hundredths, in 1/4, and you can do 1/4 as a fraction, but 1/4 of a second, Danny will be at 51 feet. Okay, so what you're doing is you're following these steps. Think about where they're starting, what's the velocity, what the height's going to be, the maximum height, and how long it's going to take to reach it. But that is what you're doing for these problems here on all of these. When you're finished, ask the sub to check. Like, there will be an answer key provided, and not online though, but answer key provided that you can check against that. Okay, this is due tomorrow. If you finish before the end of class, I do want you to turn it into the tray so I can see it first thing Thursday morning. You will then, I'm going to be releasing the scores for the EOC so you can see which ones you missed, and it tells you, like if you missed it, what some issues could have been. I think you can start doing some of these problems. I'll wait on that. So, okay, that's what I want you to do for Thursday the 24th. Thank you.